For decades, engineers have relied on enormous tube-like machines with a terrifying array of cutting wheel, blades that eat dirt for breakfast when attempting to construct underground tunnels. When excavating a path for London's recently opened Elizabeth Line Railway, these giants known as tunnel boring machines, or TBMs, were used. These expensive machines are frequently custom built for each project. The equipment used for that project was over 1,000 tons each, and it dug tunnels with a diameter of over 7 meters beneath the British capital. However, HyperTunnel, a British startup, has other plans though. The company envisions a time when a much smaller, half-cylinder shaped robots that are about 3 meters long and travel through pre-drilled pipes underground. These pipes, which would have a diameter of about 250 millimeters or 10 inches, would trace the outline of the proposed tunnel's walls. Once inside, the bots would drill small holes into the surrounding earth using a robotic arm equipped with a milling head, which would later be filled with concrete or another sturdy material. The structure of a new tunnel would be put together piece by piece in this manner. Patrick Lane Knott, the director of engineering at HyperTunnel, states that we're talking about thousands of them, swarms that operate similarly to an ant or termite colony. A 3D animation of the robots working on a fictitious gigantic underground structure can be seen in a company video. The process, however, would resemble tunnel construction done backwards. Using a TBM, you dig the hole first, then construct supports or walls to keep the earth surrounding the opening at bay. According to Lane Knott, we dig the hole first, then we bury the tunnel. The material filling the tunnel's chamber can be taken out after the structure has been constructed. He contends that this has the benefit of requiring less material for construction in general. The outer thickness of the structure could be adjusted to accommodate the actual geology and pressure surrounding the tunnel at any given point, rather than installing uniform sections of tunnel wall along the entire length of the project. It can take years to design and construct a TBM before using it to actually dig a tunnel. So according to tunneling experts, the industry is in desperate need of technological solutions to cut costs and increase efficiency. Elon Musk's boring company HyperTunnel and other companies are working on brand new high-temperature techniques for blasting through the hardest rocks on Earth. These are just a few of the new businesses promising to change things. According to Jasmine Amberg, project manager at Amberg Engineering, an underground construction firm founded by her grandfather, there's a lot going on, and I think that's good because the tunneling industry has to improve. She thinks tunnel boring needs to become a faster, more sustainable industry. Additionally, there is a plentiful supply of employment. A 20-kilometer railway tunnel in the Longmen Mountains was recently finished by China after a decade of construction. There is the HS2 rail project in the UK, which will link London to towns and cities in the north of the nation. The project's proposed route is expected to include more than 100 kilometers of tunnels. A bold plan to construct an underwater tunnel connecting Finland and Estonia is being driven by Peter Vesterbacka, a former employee of Angry Birds creator Rovio. There are just a few illustrations. Amberg predicts a rise in demand for underground infrastructure, not the least of which is to escape the rising temperatures above ground brought on by climate change. Having a location with more consistent temperatures might not be all bad, she suggests. Not only for transportation are tunnels used. Troy Helming, the founder and CEO of the San Francisco-based startup EarthGrid, emphasizes the necessity of burying power lines because this is what his business aims to do. He points out that in the United States and Canada, the vast majority of transmission cables are above ground, leaving them vulnerable to hurricanes and other storms, as well as increasingly wildfires. He holds up a map with colored lines, showing a grid that stretches from the eastern seaboard to the Pacific Ocean, with future offshore wind farms in the west, and declares our plan is to put a supergrid across North America. This plan has the potential to connect the US grid and perhaps even one day reach as far as Europe to take advantage of the enormous offshore wind potential there. We are aware that it is crazy and audacious, says Helming. One difficulty is the extremely hard rock like granite and quartzite that makes traditional excavation in some of these locations difficult or impossible. Helming believes that plasma torch technology, which blasts rocks to smithereens by heating it to a temperature of about 6,000 degrees Celsius, will provide the answer. In comparison to current technology, he claims that this could make it possible to drill tunnels 100 times more quickly in hard rock. According to Helming, EarthGrid will have a working prototype of the 5 plasma torch wielding robots by March 2023. By the end of this year, the company also hopes to finish its first modest commercial project. Helming observes that in the case of EarthGrid, the tunnels won't be circular but rather traditional horseshoe-shaped. Picture a square with an arch on top, as opposed to a flat ceiling. He contends that by doing this, it will be simpler to install cable racks or, in larger transportation tunnels, a road surface on the flat base of the tunnel. Rival company Petra also seeks to pierce hard rock using the power of heat, but employs a thermal cutting tool that uses a superheated fluid rather than a plasma torch. According to CEO and co-founder Kim Abrams, the idea is to slice through nightmare geologies with reasonable ease. She explains, "We finished a 34-foot, 30-inch diameter tunnel in granite just last week," and adds that the business hopes to start doing commercial work in 2019. And she says the business is also working on a different approach to deal with the other end of the spectrum, extremely soft or waterlogged soil, which is frequently found beneath and close to coastal cities. According to Amberg, these tunneling technologies have yet to demonstrate their viability in a large-scale setting. She finds the idea behind HyperTunnel intriguing, but adds that she is unsure of how the robots will handle more challenging geologies or waterlogged ground, for example. Professor Jian Zhao teaches in the Civil Engineering Department at Monash University in Australia. He and his colleagues have looked into the use of high-pressure water jet, microwave, and laser technologies, among others, for tunnel boring applications. He doubts that, for instance, Petra's heat-based method will be adequate on its own for massive tunneling projects, but he wonders if it might be combined with mechanical excavation. According to Michael Mooney, the Grucock Chair Professor of Underground Construction and Tunneling at the Colorado School of Mines, the seed funding, angel investing, and all that to fuel some of this innovation, I think is fantastic, although he acknowledges that the jury is still out on whether any of these new tunneling technologies will achieve widespread commercial success. He emphasizes that faster, less expensive techniques are highly desired in the sector. He also contends that the Boring Company, which is developing a unique type of TBM that can be launched from the surface to create underground tunnels instead of the traditional method, which involves first digging a hole and then lowering the TBM into it to form the tunnel, has innovated in the sense of business because the company intends to standardize tunnel boring tools across projects. According to Mooney, building a new tunnel boring machine for a specific project each time adds complexity and cost. Amberg concludes by pointing out that the numerous tunnels already in existence, many of which are in her native Switzerland, need to be maintained and repaired due to aging. For this work to be completed effectively, new technologies are needed. HyperTunnel is one company that focuses on such markets in order to maintain the exterior structure of underground tunnels. Lane Knott's company's bots will be able to whoosh down pipes without requiring operators to halt the road or rail traffic inside, he claims. And this uprising is already underway. According to Lane Knott, HyperTunnel has been hired for a project along these lines by Network Rail, which owns and runs a large portion of the rail system in Great Britain. It's a small step towards his vision of the power of the swarm, in which thousands of robots collaborate to build enormous underground structures. Our future will be filled with tunnels, swarms or not. There is a race to find out who will dig them up and how. Thank you for tuning in to our channel. We hope that you found our content informative and engaging. Our goal is to keep you up to date on the latest trends and innovations in the world of technology and science. If you haven't already, be sure to subscribe and hit the notification bell so you never miss an upload. We love hearing from our viewers, so please leave a comment down below and let us know what you'd like to see in future videos. Until next time, keep exploring and experimenting with the amazing technologies that are changing our world.